parallax, there's a phenomenon where we can use our thumb. So everybody put your thumb in front of you, up. And what you're gonna do is you're gonna close one eye, look at your thumb, and then close the other and open that. So switch on and off between opening and closing every other eye. What do you guys see? Yeah? Yeah, so it's shifting depending on which eye is open and which eye is closed. So, if we go back up to this diagram, basically here, you can actually see it. We have our nearby star. So if we're on Earth, and this is June, we're seeing the nearby star in position B. If we're in January, we're seeing the nearby star in position A. So depending on where we are around the sun in our orbit, we can see stars in different positions. So we're going to calculate the positions of stars with planets and the distance to neighboring star. You will be using parallax to measure the distance to stars. Using the distance between our sun and planet, we can determine how far away a star is without actually measuring that distance. This lab is designed to show you on a small scale how we are able to get distances of faraway galaxies even though we have never been close to going to those places. So before we get into the pre-lab questions, for this lab, we need to remind ourselves about accuracy and precision. So what does accuracy mean again?
How close the thing is to the target value.
And then precision?
How consistent your values are.
Yep, that works. So, how do you think we measure the distance between planets and stars?
Starts with a P.
I heard it. Somebody whispered. Yeah.
So they take a yardstick and they put it on the surface of the moon.
Yeah, right? If we were that far, I think we would probably burn from the sun. Or that close. Okay, so. I already looked up the definition of parallax for you guys, so you can just record it on question number 2, and then for number 1, write the answer, what we just discussed. Earth in July, and the other is Earth in January. We hold our thumb out, and we see the shift. That's exactly what's happening here. So the nearby star, when the Earth is in July, we see it down here, and when we're in January, we see it down here. But the star itself isn't actually moving, right? But where we are, based around the sun, changes our view of the star. So we have to remember that the star itself isn't moving, but our view is shifting based off of the direction we're looking at. So, if we go back to our lab, what we're going to do is, I have an example up here. We have our near star, which is for us, our sun. We have a planet, either A, B, C, D, or E, and then we have a distant star. So we're trying to find the distance between planet B and the distant star. So first, to get that, we have to measure the distance between our sun and the planet, and then we also have to measure the angle at which the distant star is from planet B, and then we have to measure the distance from the near star to the distant star. So like we did in our practice questions, this would be the angle, this is the distance. So we can use this distance and the angle to find the tangent, the hypotenuse of this angle. So, you guys understand that a little bit? So in your lab, you won't have this line. So what you're gonna have to do is grab a protractor. You guys have used protractor before? Yeah. You go. And a ruler. Measure from the middle to the middle in centimeters. Get that number. The center of the protractor, this little dot that you can see goes in the center of the planet. And then with a meter stick, you're gonna line up like the corner of the meter stick with the center of the distant star. And then make a straight line down here from this dot, and it'll give you the angle. So here, the angle is 50. So if you flip your lab over, there'll be a table where you can fill out all this information. So, distance of planet to sun, or sun to planet, angle of planet to distant star. We're going to use these two numbers, the angle and the length, to calculate tangent. And then we're going to measure the sun to the distant star. After we get all of these measurements, we're going to calculate our percent error. So here we have the formula for percent error. Theoretical value minus experimental value divided by theoretical value, the absolute value of that times 100. So in this case, which numbers would be our theoretical value? On the table. You guys remember?
Not really.
Yep. That would be our experimental value, because we're finding that through calculations. So if that one's experimental, which one would be theoretical? Not that one, the
Yeah.
other measured distance.
The average? Or is that for yellow?
It would be the distance from sun to the distant star. So it's going to be this value minus our tangent value divided by this value again. And we take the absolute value of that and multiply it by 100. If you guys have questions while you're doing it, I'll come around and help. So I'll show you on the worksheet up here. So this number is going to be theoretical. This number, experimental. Okay? So you guys can write that down to remember it. Alright? So, for the lab you need a protractor, a ruler, a meter stick, and a calculator. On the back left board we have planet B, planet C is on the back right. On the table where Miss Lewis is, there's planet A, planet D,
Wait a minute, this one or that one?
Where's planet A?
right here,
Oh,
on the table.
this one? Mom. Imagine this is from sun to distant.
Should we do the angle first? Talk about these.
And then the last one is 34. It's 34.
So make sure you line up the circle with the center, yeah, there you go, with the center of the planet. You could even use your meter stick and line it up with the center of the star and the center of the planet so that you get a nice straight. And then line your protractor up with that. Just bring it down a little bit. Bring this down a little bit. Line this in the middle. Ah! There you go.
I got 37. I got 37.
2 and 3 coincide.
So what's next on the table to measure?
Like this? Or you
Oh, you got them for A? Where's D?
Which one's
Did you finish D?
Nah.
Where'd you get 80?
Isn't this D?
This is A.
No, we started that one.
Wait, but that's one spot you put it over here.